All right, so we left off with this interval we just found, and I just wanted to reiterate again that, if you notice the interval goes from negative, say, 1300 to 2900, notice that 0 is within the interval. So if I had to determine, is there a true difference in the mean number of likes for tweets, I would say no, since 0 is contained in the interval. So if I were running a significance test, which is what we're going to look at, I would end up failing to reject HO in that case. All right. So speaking of significance tests, right, when we look at this, we did the confidence intervals. So then we have our significance tests for mu1 minus mu2. Right, so two means. Okay, so I'm going to start with the hypotheses, right? Similar to proportions, right? We've talked about that before. Parameters, of course, are still the same. You still have to define both parameters, define what mu1 and mu2 are, in words. And then the hypotheses, right? HO. And again, you have some options. I'm going to stick with this first option. I'm going to write mu1 minus mu2 equals whatever the hypothesized value is, right? So typically, we're going to say it's going to be 0, right? But you're going to notice there are times where maybe that might not be 0, that they are different and they differ by at least 3 or by at least 5 or something. Then that would change. But the hypothesized value, we're assuming these are equal. There's no difference, so that would be 0. And then your HA would be mu1 minus mu2, and this could either be a less than, say, 0, or whatever that value is here, not equal to 0, or a greater than 0, right, is one of your three options. Okay, so that takes care of the hypothesis statement part. All right, and then you get into B, your conditions. All right, so for the conditions, we're going to just kind of revert back to our confidence interval ones, right? Because they would be the same set of conditions. Okay, so we're just going to say C confidence interval for mu1 minus mu2. All right, so that being said, right, we've got another example to do that takes those into account so you can see them at work. And here we are with Mrs. Gallus. Gives us some data, right? It looks like there are 40 students in each version, right? So I'm just going to add the N, right? So that'd be 40 and 40. All right, so state the appropriate hypotheses. So for part A, we have right, the parameters, right? So mu1, or I'm going to actually say mu A in this case, is the version A, right? So two different versions of the final. She wonders if the difficulty is the same for each version, right? So for part A, this would be the true mean score for students on version A. And we're going to say mu B is the true mean score for students on version B. Okay, so HO mu A minus mu B. We're going to assume that's 0, right? Assuming that there's no difference. And A minus B. We're trying to show, does it give convincing evidence that the difference in version A and B? So we're just showing, is there a difference? So this would just be, could be a positive difference, could be a smaller difference, right? But it'd be not equal to 0. And then we're done. All right, part B, conditions. Right, so we've got the random condition, and the random condition, 80 subjects, right, or 80 students were randomly assigned to A or B. All right, so there's your random condition. All right, that checks out. 10% rule we don't actually have to do, right, because it's an experiment. We're not sampling without replacement, so I can bypass that. And then the normal condition, right, or the large sample condition, they both have, so N1 is equal, I should say equal to 40, which is greater than or equal to 30. And same thing with, well, I should say NA. And then NB is the same. So both of them are at least 30. So that means I have a normal sampling or approximate normal sampling distribution anyway. All right, so there's that's it. Oh, and then yeah, then we're done. That's it. Okay. So moving on, that's kind of the first half, kind of like what we did before with the proportions. If we're doing the second half of a test, so that took care of the parameters, the hypotheses, the assumptions, right, or conditions. Now we get into the names and things like that. So same data, right, that we had before. We already confirmed the conditions are met, right, so we don't need to redo that. So part A, and just so we have it, I'm just going to rewrite our null and alternative down here. So mu A minus mu B equals 0, and mu A minus mu B doesn't equal 0. All right, so there's our null and our alternative. And as far as that goes, we have the sample results, right? And that's just simply going to be if you took the X bar A and X bar B, then you have your answer, right? So we can say X bar A minus X bar B, right? And subtract the two. So 84.2 minus 79.9, right? And that's going to give us, what do we got there? 84.2 minus 79.9, right? So 4.3, right? And 4.3 is obviously not 0, right? So we have some evidence right there. Okay. To that, because it's not 0, right? But is that enough to, say that the two versions are different, right? Or is that just something that happened by random chance, right? Which is why we make the standardized test statistic. So with that, this is a t-test, right? So this would be a 2-sample t. So I'm going to have my t interval, or sorry, not my t interval, my t statistic. Take my estimate, right, which we just found was 4.3, minus the null value, which is 0, over, and then I'm going to have my standard deviation. So 8.9 squared over 40 plus 12.3 squared over 40. And calculate all of that out, right? So we end up, I got a 1.79, right? It should be divided by 8.9 squared over 40, and then 12.3 squared over 40, right? 791, right? So there's our t. We know the degrees of freedom, right, is the small. They're both the same, so there is no smaller of the two. So our degrees of freedom is 39. And then our p-value, right, I'm going to use a t CDF, right? So second vars, go down to T CDF, and I'm going to put in 1.791. Degrees of freedom is 39, paste, and that's going to give me 0.95. So I could do a 1 minus, right, since it's on the right side. But then I do need to double it, right? Remember, I have to double it because of it being a two-sided test, right? So double it, and I end up with 0.0811, right? So 0.08, oops, messed that up, 0.0811. All right, so there's my p-value. What conclusion would I make? Right, as far as that goes, part C, since 0.811 is, what was our alpha? I think it was 0.05. Yeah, our alpha from above, right, it's 0.05. So this is greater than 0.05. So that means that we would fail to reject HO. And we would say that there is not convincing evidence of a difference in true mean scores score of version A and version B of the final. Okay, so that's it. So stay tuned for part 4. I think it is part 4. It's just going to be one example. It's kind of top to bottom for you. All right, so stay tuned.